Verify the identity cosine of x over 1 plus sine x is equal to 1 minus sine x over cosine x. This is a really kind of cool identity just to see written out. It might even seem surprising that those two sides are equal to each other. We have to pick a side to get started. I would actually claim that they have an equal amount of complexity. So if I didn't know what else to do, I would randomly pick one, or flip a coin. I'm gonna pick the left-hand side, because sometimes you just have to do something in a problem solve if you're gonna solve a problem. All right, so I have cosine over 1 plus sine x. Not a whole lot to think about doing here, but I see a 1 minus sine x over here. And that gives me something to think about, because I know that 1 minus sine x and 1 plus sine x multiply together in a very nice way. And just by multiplying top and bottom by the same thing, I know I'm not changing the fraction, and it puts that 1 minus sine x on top, and I know it has to get there eventually. What did I really do? Well, I'm multiplying by 1, right? I'm multiplying the top and bottom by the same thing, so they divide out, and I'm really just multiplying by 1. So let's see what happens here. On top, I'd have a cosine x times 1 minus sine x. On the bottom, if I multiply that out, I get 1 minus sine squared x. All right, so I've multiplied. 1 minus sine squared x is cosine squared. That's a Pythagorean identity. And now I see on top I have a cosine, and it cancels with one of the ones on the bottom. Canceled a common factor, and that is equal to the right-hand side. We verified this trigonometric identity just by multiplying by something that appeared on the other side. But the thing I want to really point out is what's happening here, right? With that plus and that minus, I'm getting a 1 minus sine squared here, right? And I can use a Pythagorean identity. These are thought of as trigonometric conjugates, right? And you've multiplied things called conjugates before when you've dealt with complex conjugates and when you've dealt with irrational conjugates. If I think about 2 plus 3i, its complex conjugate is 2 minus 3i. And then the first time I ever multiplied these together, I would have thought I had to distribute. 2 times 2 is 4. Minus 6i plus 6i, and that was the big deal, right? These middle two terms cancel, and then I get a minus 9i squared. I is the square root of minus 1, so I squared is minus 1, and I just get the real number 13. Conjugates always multiply together nicely with irrational numbers. If I had 1 minus root 5, its conjugate is 1 plus root 5. And again, I kind of go through the same process. 1 times 1 is 1. Root 5 minus root 5 cancel, and then I get minus 5, right? Root 5 times root 5, and I get a whole number. Conjugates multiply together nicely. These two trigonometric conjugates let me use a Pythagorean identity. All right, so I had picked the left-hand side. You can also pick the right-hand side and use the same idea of multiplying top and bottom by that trigonometric conjugate. And I think that's a good thing for you to try right now.